Title, Rise of Autonomy for COVID-19, I think some of you guys may have already joined one of our uh, first series, which is episode 1. And that episode 1 was actually discussing about the platform, or what robot are you trying to use. So either you can just buy the platform directly, or you can actually create it from scratch. But with the interest of time, or let's say you're trying to create a robot itself, there are things that you might need to just buy off the shelf, right? So it means that, let's say, you don't have time to 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 create the robot. Why not just buy it? But there's something that you need to consider, like, is it ROS compliant, right? So for this webinar, which is titled Rise of Autonomy COVID-19, which is episode 2 for the middleware, which is we're going to use ROS, right? So I'm Ian Alferez, and then I welcome you to the webinar. So let me begin with the first slides, right? So I think if I go back to one of our previous slides, it's actually telling that there's now more autonomy in robotics, right? So I think you can see it here that instead of just having a AGV or a ground vehicle robot, there's now adding some complexities to it. So it means that I'm going to add a robotic arm with that AGV, right? Or mobile robot, right? And it adds another dynamics. And this means that you cannot just control it by a normal control system. You might need to bring in all the other things necessary for the robot to understand its environment and precisely do the task that it was assigned to. So let me just admit the people in the, I think they're all admitted. Yep. Right. So yeah, so again, there are more complex. You need to simulate. You need to make sure that the control system is working perfectly. The perception algorithm is working fine, and you need to have this test cases, and these test cases and these scenarios should be able to accomplish that specific mission. So I think if I go back to the slides again, going back to the original slides that we have presented last Wednesday, was that you can probably see especially in Singapore, you can see a lot of this robotics or this AI stuff being deployed around, because I think that's something new, and it's something that we will see more often in the future, right? So by now, there's really a lot of interest in creating your own robots to make sure that you're going to deploy this one for a factory or for social distancing measures, or making lesser people in the field or the working environment itself. So this is something that we will see a lot in the future. But this is one of them, right? So it's really, really quite current. But our topic today really focused much on another part, right? Which is basically, if we look through the whole autonomous systems itself. For this episode, we'll talk more into the robotics toolbox, or ROS toolbox, right? So we'll talk about that. Why we're going to do that? It's because it's one of the most important things to really get started with robotics, and there's already a lot of robots that is readily available for you to just plug it in and add in your perception algorithm, add in your controls algorithm, path planning, navigation, and whatnot, right? So our agenda for today would cover this 3 demos, right? So we'll try to communicate MATLAB and Linux with ROS 1 or ROS 2, right? We'll try to simulate a TurtleBot using ROS 1, right? And then later at the demo number 3, which is basically we're going to use ROS 2. It means to say the new ROS is basically is supported by either MATLAB or Simulink. So it's basically an application wherein it's doing a navigation, but it's a very simple navigation. It's just a if-else statement and trying to look or follow a certain mission based on a maze or based on a certain environment. And then later we summarize everything, right? So let's begin with what is ROS, right? Who makes ROS? Basically, it's done by this this organization. It's Open Robotics, and basically they are working together with industry, academia, government to really create this ROS, right, or robot operating system. And then you can probably see the most popular one is you say ROS, Gazebo, Arviz, and such is basically from here. Right? So if you think about it, ROS is not really a operating system. It's just the name points into it as an operating system, but definitely it's not an operating system. It's basically a middleware. So in my case, my background is actually in the automotive industry. One thing that we normally use is instead of creating your own library to communicate or do a communication between different microcontrollers, basically you need to use environment for a way to communicate from one controller to another controller. Basically, you're using some architecture, and that's something that we used to call AutoSAR. So in this case, for automotive, it's quite nearly similar to ROS, but for this topic, we'll probably cover that one here, specifically for ROS. And I think if you go through their citations or the number of downloads of ROS, it's basically exponential, right? So you can see this one is the data set from 2018, but you can see there's a growth over from 2010 or 2011 to 2019 or 2020. So one thing you need to understand about ROS is that there's this what you call communication paradigms, right? And if you think about it, it's just basically two different nodes or multiple nodes trying to talk to each other, right? It depends on how you architecture the environment. Some people will combine all of these nodes that it will contain the planning, localization, motion control, obstacle avoidance, global map, and other things, right? But you can actually try to modularize it, and then it makes it easier for you to maintain the said application or a specific software stack for your robots. But in this case, for ROS, it's basically just saying the control node or the localization node, the motion control node or the obstacle avoidance node, and then they're trying to send messages throughout the communication or throughout the RTE or runtime environment. And these are very common concepts in ROS. So you will have these terms quite often. You will have topics, services, actions, and parameters, right? So if you want to send a message or you want to receive that message, it's basically just publish and subscribe. If it's a service, so it means to say that there is a server and client relationship, then it's basically services, which is request and response. Actions is basically the results, right, or the goal and feedback, and then some parameters. So parameters would be maybe your PID controller, your settings in the control systems that is specific to how would your node would work. Right? So it's basically the constants and the parameters that it's going to look at too. And yeah, you can again go to wiki.ros.org to go for that specific tutorial on what it is really. Right? And basically, it's just a structured message data types. Later, we'll see how it looks like in MATLAB. And basically, it's just a very straightforward communication protocol with different has it text file or a structure. So if we talk about ROS1, it's basically you need to have these three things that should be here, right? So if you're trying to set up a ROS1, so you need to have a ROS master. So the ROS master can be any one in the node, and the node would be some applications, right? It can be in the same Linux operating system and with the ROS master. And you need to have this ROS master because it's the one to say ROS1 node A is trying to send some information to ROS1 node B, and so on and so forth. So this is something that you need to settle, right? So this is the most key important thing for ROS1. And basically the server, it's basically the ones who handles all the message. But now with ROS2, the latest version of ROS, is basically there's no more ROS master, and there's a direct message transfer from nodes to nodes. And this is through what you call TDS, or it's basically the thing to push the message or publish subscribe throughout the whole communication bus or the communication setup. So now instead of having a ROS master, they would have a TDS or middleware for that, right? And so if I go to the next one, right, which is basically getting started with ROS and MATLAB and Simulink, we do have like a different way to use ROS, right? So one of them is basically you can bridge them together using, sorry for this, let me try to move that. So basically we want to use different types of algorithms, right? So let's say you might be developing controls, you might be developing perception algorithms, you might be developing planning and decision-making for autonomous system. What we need to do is basically link them together. So if it's going to be offline, right, you can always do a recording using ROS bags. They term it as something like a log file, right? So it means to say, I can walk around with a robot or walk around with a sensor, and then later I'll just have a recording of this and then run it with MATLAB later at the end of the day. Because by right, you cannot really just run your algorithms in the environment or the real environment. And other things is that you can really just communicate directly to ROS and MATLAB, right? So you can do a desktop prototyping, you can extract files, you can send commands through this way, right? And the other thing is that one good thing about MATLAB and Simulink is that we can always generate C++ codes. And one thing that we can do is that when we generate the C++ codes, we can actually automatically wrap it, and it will become as a ROS node. And that's something that probably is quite interesting to use, because I experienced it before that I need to write the C code. Then after writing the C code, I still need to wrap it with a ROS wrapper so that I can send messages or receive messages and do my algorithms. And that's quite tedious. There's a lot of things that you need to set and need to make sure that it's going to work. But here, MATLAB can just one press of the button address to that specific IP where you want to download that specific ROS node or transfer that specific ROS node. Then you can just say press the button, and that's it. And basically all these things can be done using ROS Toolbox, right? So there's some examples that I can show you later on, but this is like the high level overview of how you would probably write a algorithm or a communication with MATLAB and ROS. So first thing is that you need to make sure you have properly set it up. What I mean by properly set up is that you need to point to the IP address. So by right, your ROS nodes will be communicating through the IP address, and MATLAB would be one of the ROS nodes. right? So then you can bring in the sensor data sets and then try to do some pre-processing. Maybe it's image data sets, or it's going to be LiDAR data sets. Is it going to be radar data sets? And then you need to do processing. And after understanding the environment is that you're going to control your robot, right? And then maybe you have some visualization if you need to. Okay? And this is like a very simple pseudocode for that. You need to make sure you know the IP address of the ROS master or that ROS node. Then you have this ROS subscriber. So basically, messages are termed as topics, and then you can be a publisher or become a subscriber for that, right? So this is like a very standard set. So sensing, let's say you want to get that information from that subscribe data sets. If you want to create an algorithm based on that received data sets, then you have a controller out. Then if you want to publish it out, then you just say, send my pub message. And that's basically it. If you're using Simulink, then I think we will provide what you call blocks for this. And this is basically the old way of doing it because it's still ROS 1. But you can probably see now that there's like a block for a subscription. There's a block for publishing, right? So this is like a very standard template for Simulink in with ROS. So later I will share this or how you can probably do this. So it's quite similar to MATLAB, right? But MATLAB is more towards scripting. But Simulink, it's really nice to look at because you can see here you have you can group them into to specific areas, right? Like this is for sensing. This one is processing. This one is just for verifying the algorithm, and this one is basically my control stack, right? So you can have a very modular set of software stacks, and you can just integrate them together. So if you're the systems engineer, this is something that you would really like to have because you can simulate them together and then bring them all together to accurately parameterize your systems for that specific application. And there's a lot of way how you can model your algorithms, right? So there's, let's say you can use MATLAB Codes. If you're familiar with MATLAB Codes, it's basically just a high-level language. You can use Simulink blocks. So here you can probably see there's like state machines. So state machines is really good at supervisory logic. And then you might have some low-level controls. So low-level controls might be it's a PID, it's an MPC controller, it's probably something like a LQR controller or whatnot, right? So basically, you can combine all the necessary things based on what you really like, right? So we cannot say, oh, you are really good at MATLAB, so you use MATLAB. But here we can say that there's a tool that is really good for that specific application. So if it's supervisory logic, I would prefer using Stateflow or state machines. If it's PID controller, low-level controller, I would definitely use just Simulink. If it's more towards statistics analysis, perception, image processing, LiDAR processing, I would really prefer using MATLAB. And then the good thing is that you can combine them in one environment, right? So let's start off with the hello world, right? So how do we get started? So here is just a very simple example, right? So what I have is basically just two nodes trying to talk together, but it's actually using ROS2, right? So I have a video here. It's basically if you're not familiar, ROS will be running on Linux, right? There's a way to run it in Windows, but I think the most popular way of doing this is through the Linux environment. So you need to install the ROS bouncy or ROS melodic. And from here, you can actually just say, this one is just an example, but it's just saying, I'm going to publish hello world, right? And I'm counting that, right? And in my MATLAB, so this is a two separate system. Then my MATLAB, because I'm using ROS2, there's no more declaration of the ROS master. So I can just say ROS domain to 25 that I'm going to look for that topic list. So what I'm actually trying to pick out here is basically this chatter, right? So this demo node CPP is basically it's sending out this chatter message, and I'm going to bring that one in, right? So here I can just say ROS2 subscriber, the node 1, which is basically my MATLAB, right? And chatter, I'm just going to get the string. So basically I want to get the string here. And then I would just say it's receive, and then you can probably see it points me to hello world, right? So if I'm going to run the script over and over again, then probably you can see that hello world is changing to 32, 35, 36, or 37. But what if I can just say, can I do a for loop or a while loop? Then yeah, it's basically, you can just do that. So I'm just going to write in a for loop for that counting, right? And then you can see here, it's just really just iterating once there's a new message. And basically now I can see that I'm actually communicating with the ROS node in, in Linux, right? Running in Linux. And my MATLAB is running on my desktop PC, though I'm using VM for this, but the concept would be the same. So if you have a TurtleBot, or you have a Jetson Nano or a Jetson TX2 who can run Ubuntu, if they can be, if ROS distributions can be installed there, then I think it should be fine. I think there's no problem for it. And the good thing here is that since they're communicating through IP, you can probably just plug in a Wi-Fi card or a USB Wi-Fi to that specific embedded Linux, and then you can run it and play around with it. Okay. So let's go back to another example, which is basically we will use a TurtleBot, right? So by right, I with the interest of time, I don't want to go down to how the TurtleBot is made. You can definitely just download it, and then they would have a raw TurtleBot package, right, for your gazebo or your harvest. And here I just run a very simple example. It's still using, so do take note, I'm using ROS1 here, and just to show you the difference, right? So here I'm using ROS1, and basically the ROS1 is a bit different. The differentiation, the different of the two is basically there's a function here inside that I need to declare the ROS master. Where's the ROS master? Where's the, yeah, something like that. So I need to declare that one. So here, I'm just saying ROS topic, then I get the list, right? So the list of messages that I can play around. And you can see if you have a gazebo with the TurtleBot, it can be any TurtleBot, but once you run this one, you can probably see all the things that you can control the robot and all the sensors that you can extract out, right? So I think if you can see here, command vel is basically trying to tell how much is the velocity of the robot moving forward, right, or backward. There's this, and some other parameters that you can play around. So scan would be your LiDAR, right? If you have a camera sensor, then you might need to update the ROS topic based on the gazebo, but that's something that you can play around, right? So let me just continue with the demo, and here I just say I want to be subscribed to the odometry, right? Then I can get that one out, and then I can see here I can get the position and the orientation of the robot in terms of the pose and the twist, and then since you can see here, since I don't have this raw image topic, since this robot doesn't have any camera sensor, so basically it tells me that I cannot reach the topic. Basically, it's not there, right? And then other things in that is basically if you have the way to control it. I'm just saying. I'm sorry. I'm just saying that. Sorry for that. Basically, I'm saying here. You can command the robot. If I run this one, right, over a certain period of time, then I set to 0, right? So you can see I'm sending a linear value and an angular value for the z, and then basically it's going to give me that movement. Sorry for that. That's good. Right. So it's just going to turn based on the given commands that I said, and then it's just turning around. All right. So pretty straightforward, right? So if I move on to the next demo, basically instead of using ROS1, I'm going to use ROS2, right? And here, basically what I want to do is, the mission here is basically I want to follow a certain sign, right? So this is like a very, very relaxed controller. It's just saying if it's pointing left, then you need to turn left. It's pointing right, you need to turn right until I found the stop sign. So there's a stop sign here, right? So I just say once there's a stop sign, I will stop the simulation. But it's very, very, very straightforward control. The navigation and the slam would be like, I think I will reserve that one for the next webinar series. But here it's just a very straightforward control system, right? So if I'm far from the object, then I need to move closer. If it's telling me that I'm going to move left, then I need to move left. If it's telling me to move right, I need to move right. If it's telling me to stop, then I will stop the simulation. Right? It's a very straightforward algorithm. So what I have here is, again, I run the gazebo, right, with the environment. So you can see here, it's actually using the burger robot, right? So there's a burger robot here. There's some signs of the robot. And then what I need here is basically, I just need to run the MATLAB script. So one good thing about this MATLAB script is that there's actually what you call a Stateflow or chart here, or state machine. So this is actually the sign following controller. So in the latest release of MATLAB and Simulink, Stateflow can actually be used in the MATLAB itself, right? So I'm just going to run this one. And then once I run, you can probably see that this sign controller, I'm just going to open it. It's basically waiting for the command to run, right? So I'm just going to press the play button. For this, basically, I have a while loop for the said robot, right? So to control the robot, and you can see now it's moving forward based on the setup. I open up the RViz, right? So RViz is basically one of the tools that you would use to visualize sensors or anything from the robot. And then you can see now it's actually moving. Since the robot has a camera sensor, it also has a LiDAR sensor. And then with the state machine, right, you can actually see that is a very good way of programming. But right, like that's what I've told you, I'm from the automotive industry. This is typically what I use. And this is really one of the nicest thing to make sure that the algorithms that I'm working on is the same thing as I've been planning or making, right? So this is a really nice way of visualizing at the same time programming your algorithms. And then you can see once it knows that I'm in, I find that there's a object that I need to turn right, then it goes turn in place. Then after that, it actually goes to the state, scan for the object, it's looking for the object, then go back to the track algorithms. But this is like a very straightforward if-else statements, but it's actually going to move until I find the stop sign. So I'm just going to move forward. And then at the end of the day, I was able to look for that stop sign. Right, so there's a stop sign. I think I need to move forward a bit. And then after a certain distance, I'm going to stop my simulation. It ends, and then that's it, right? So let me move down to the next topic, right? So basically, that is in MATLAB. So this is a MATLAB script, right? But what if I can use Simulink, right? So here is the same demo, right? I'm going to say it is the same demo, but instead of using scripting, I'm going to use a combination of scripts, a combination of state machines, at the same time, combination of Simulink blocks, right? So I'm just going to press the play button. It's the same thing. It's the same algorithm, but now I can see it as a modular application, right? So it's the same. It's the same environment. I still have my RViz with the point cloud data sets. I can also get the camera sensor later on, but the idea there is that I can go for the image processing. If I double click on that image processing, basically it's the pre-processing for color thresholding. It's still MATLAB scripts, and I can go to the sign following logic. It's the same thing as what I've shown you earlier for the MATLAB environment, but the differentiator for this is basically you have blocks for your messages, right? And in MATLAB, you can just say, I'm going to press the play button, right? And then you can also visualize them all together. And then let me just move on to the environment. It's the same, really the same thing, but I have a better overview of the whole system. And you can see if I move forward to the end, it's still solving that specific problem. So there's no difference in terms of the algorithm or the control, but it's how do you feel where you're comfortable in. And Simulink is one of the best environment to really expand the control algorithm. So this one is a very, it's a very simple algorithm. It's just saying, I have a color, I need to check on that color, and then based on the distance of that color, or based on the sign of that controller, I need to move left or I need to move right. And basically, it's giving me the same environment. So this is probably what you call cost simulation. So when we mention about cost simulation, you're running your gazebo environment at the same time your MATLAB environment. And then when you see here, it's not really real time. It's a soft real time. So there's a pacing here that's happening. So your gazebo and MATLAB is running at the same time, but there's a pace, right? So it controls this. I think gazebo is the one controlling this. I'm not sure, but there's a way that they are passing information over time. So you can probably see here that it's near real time, but it's definitely soft real time. And if you really want to deploy this one to an embedded system, it's actually one of the advantages of using the tool of MATLAB and Simulink. So let me move on to the next step. So let's say you have done your algorithm, right? You have made a perception algorithm, or you have made an image processing algorithm based on MATLAB or in Simulink. The next thing that you want to probably do is move out of the development environment, right? So I'm not saying it's only MATLAB, but you want to move it out. Make sure it's not reliant on other dependencies, right? And then in MATLAB, you can just say, I'm just going to generate C++. And then based on that generation of that C++, it's basically you write your own standalone nodes, right? But since we do have ROS Toolbox, we can actually just automatically link that together. So this is like your traditional way of people writing C++ and then manually create a wrapper. But with the ROS, with the ROS Toolbox and the coder products, you can really just transfer all that algorithms to a standalone ROS node. I'm not going to do that demo now, but it's like there's a lot of ship demos and some examples that we can point you later for this. So yeah, so again, using the generated nodes, you can actually stop existing nodes from MATLAB. You can do an external mode, and you can basically run that node in runtime, right? So it's basically running on the actual device itself. So I have come to a complete the end of my slides. So we have been discussing for like 40 minutes or so, but this is like the getting started of ROS, right? So there's still other things that you can do, right? I'm not really talking about sensing here. I'm not really talking about perception. I'm not really talking about plan and decision and control systems. What I've shown you is basically using ROS here, right? So when I mentioned about ROS Toolbox, basically it's the communication, right? So the end goal here, what I want you to learn is that ROS is basically one of the most popular middleware for developing robotics in this space, right? So you can just buy any robot, right? Like the popular one is TurtleBot, but it's a bit expensive. But you can just let's say you have a Raspberry Pi, right? And then install ROS distribution there, and then you can already run your algorithms there, right? You can just plug in a motor, you can plug in a camera sensor for Raspberry Pi, and then basically you can create your own autonomous system. Or again, you might have a desktop PC on your, if that's okay, you can put a desktop PC on your robot, and the robot will communicate through maybe I2C or UART to a low-level controller. But that's up to you. So the good thing about ROS, again, is that you can communicate with different platforms, right? So it means to say you can combine different vendors. You can combine different organizations who's been developing the plan and decision. You can combine it with other people who's developing the control. We can combine it with, or you can integrate, the right word probably is integrate and communicate with another engineer who's developing perception and sensing. And you don't think about how would you create the device drivers, right? So it's really just there, right? Basically, you just look for ROS compliant hardwares or ROS compliant sensors, and basically you can just do that, right? So like I cannot show it now, but it's in my room. I do have like RP LiDAR. So RP LiDAR is one of the, they say that they have ROS nodes compatible with their product. I also have a Intel RealSense. So Intel RealSense do have a RealSense package for ROS or ROS2. So you can just bring in the data, right? And then instead of focusing on how to bring that data, you just need to focus more on the algorithm that is really more important, which is perception, sensing, plan and decision and control. And then once you combine them all together, you can just deploy it to the platform. Or is either you create the platform or you add on to the platform. So yeah, so I'm at the end. That's my summary for the whole topic here. Basically, again, if you're schools or if you're from the university, do take note that you can be a campus-wide license enabled university. So you can actually use MATLAB there for everyone. So you have access to all the licenses, and then you can use MATLAB for desktops. You can also use MATLAB online and use MATLAB on mobile. And actually, there's a new feature that was just announced, I think last few days ago, that there's already Simulink online.